Okay, good afternoon. Welcome everybody to this Neocortex webinar. It's our pleasure to introduce you, to the Cerebras CS-3 units through the Neocortex program. For sure, I'm sure you have heard of these units in the past, but what's new is that we'll have the Neocortex have full access to two CS-3 units. So this is a webinar that is brought to you in collaboration with Cerebras and the PSC team. And let's proceed to what's the agenda. So today we'll cover these topics, right? We'll have first a program overview of Neocortex, a reminder of how the program has evolved, in particular in terms of what did we start with when we proposed the project 5 years ago, and how has it evolved, and more recently, what is it currently evolving into. Then we'll have a Cerebras CS3 technical overview presented by Silvia from Cerebras. We'll also have a section regarding how to get access to the CS3's units on the Cerebras cloud, all of this through the Neocortex program, and a topic related to managing your allocations and how does this access to the Cerebras cloud affects your allocations. And of course, very important, how to get support and help. We'll also conclude the session with some Q&A and some closing remarks. Please use the chat function of the Zoom session to present your questions. If they can be addressed through the chat asynchronously, our team members will take care of that. But we'll try to leave some of the, some that maybe are required a discussion can be addressed at the end of the session. So just as a reminder, right, like so Neocortex is a project that was proposed in response to a solicitation in 2019. So NSF solicitation 19587. And it's a category 2 innovative prototype testbed. The project is already in what is referred to as the production phase, which means that is widely available to the US scientific community, but it continues to be a system that offers a technology that is innovative, where we're testing how does it evolve, how does it respond to your specific needs, and it's part of the mission of what Neocortex offers. Neocortex is delivered to the community, of course, in collaboration, thanks to the generous support of the National Science Foundation and in collaboration with Cerebras and with Hewlett-Packard Enterprise. So up until now, it's a project that has been awarded $12.25 million for the acquisition of the system and also operations for the past 5 years. Originally, the system looked like this. Some of you might have joined the program when the system involved an HP Superdome Flex, which in itself is a fantastic machine because it has 14 terabytes of RAM and also excellent, SSD and a number of core Intel Xeon CPUs. And this was the entry point to Neocortex. And through that Superdome Flex, you could communicate with two Cerebras servers. So minor correction here, like if we are precise, the original system was proposed with Cerebras CS1 servers. Over the first few years of the project, we had the servers generously updated to the second generation of the servers thanks to Cerebras. And as we know, in each of these servers, we have a wafer scale engine. The Cerebras CS1 had the first generation of the wafer scale engine. And then when we got the CS2, now we had the second generation, whose specs are described on the right? So 850,000 cores. And in the same size, in this big silicon, right, with 2.6 trillion transistors and 4 gigabytes of on-chip memory. More recently, so late last year, through an agreement with Cerebras, we enable access to the developer cloud of Cerebras and access to one CS3 unit in the cloud. Some of you might have been invited initially to jump on this opportunity. Later on, this opportunity was offered to every single Neocortex researcher. And with that, what the researchers gained was the ability to get to the wafer scale engine 3, which has improved specs in the wafer scale engine, so more compute cores, additional on-chip memory, and just faster accelerator. So this is how the hybrid model looked like for Neocortex, right? Since late last year, we continue to have the access through the SuperDOM Flex 1 enabled Cerebras CS2 that was served in the, well, that was hosted in the PSC machine room. Well, the diagram shows it. I didn't necessarily highlight it, but of course there was this integration through the SuperDOM Flex, a data integration to the bridges to file systems, so Ocean and Jet. But then in parallel, also access to one CS-3 unit in the Neocortex, well, the Cerebras Neocortex cloud portion. The evolution or the change that we are doing now is that in order to enable access to the latest software, right, that Cerebras supports through their CS3 units, and also in order to be able to leverage SwarmX and MemoryX technologies, we are now jumping into a model that is fully cloud, at least for the access to the Cerebras servers. So there will be access to two Cerebras CS3 servers, and then, well, they are integrated or like interconnected with SwarmX and MemoryX. So enabling the ability to drive more than one unit at once in a single job through the SwarmX and MemoryX technology. Some of you have expressed interest in this, in how this can affect your, or can, well, through this configuration, you can explore larger models, larger deployments of your simulations and whatnot. We expect in the meantime to continue to offer access to the SuperDOM Flex on-prem, well, on-prem for the Pittsburgh Supercomputing Center. And as we have seen, some users do run jobs that only leverage the SuperDOM Flex due to its large memory and compatibility with graph algorithms and similar. So this is the overview. Of course, if you have questions, we are more than happy to address them. As you all know and should have seen, it has been informed over email, and we are happy, of course, to hear your feedback. We are very interested in making sure that your research needs are fully supported as the project evolves, and we are happy to adjust as needed and help you find solutions if there is some thoughts or concerns regarding how the project is evolving. So regarding getting access, right, to, well, these resources through the Neocortex program, we continue, the managing of allocations continues to be through the Access program and the NAIR program. So NAIR, as a reminder, is the National AI Research Resource. So for projects that are related to AI and that where you can have some, where turnaround for getting an allocation can take a few weeks, and you're okay with managing that timeline, we recommend NAIR. Access, is more wide in terms of the applications and type of computing that is supported, and can have a turnaround that is in the order of a few days. But if you're in this session, it means that you already have an allocation, so your allocation shouldn't change at all. We do the charging of the use of the cloud seamlessly, so that shouldn't change in any way. So any operations that you may have need to do with your allocation, which can be extending it or supplementing it, so requesting more resources, requesting more time, you will continue to use the usual mechanisms that you use via Access or NAIR. So with that, just a reminder that there are some programs that we recommend you consider for yourself, or maybe your colleagues. So there is the ByteBoost program, which is an NSF-funded training program where you or the person that joins would participate in a week-long workshop that is designed to expose researchers, early career researchers, and also instructors and faculty to innovative hardware. Neocortex and the Cerebras servers is one of them, but you can also get access to other accelerators and technologies like GraphCore and FPGAs and similar. Please make sure you have a look. And next year in particular, we are expanding the program such that we'll have even more technologies. And regarding more information about Access, well, the usual URL, same as with the NAIR pilot program. At this point in time, I believe the Neocortex documentation should already be reflecting this evolution that I have described. But of course, you're always welcome to contact us with questions, comments to neocortex@phd.edu. And also, we invite you to leverage the office hours that are being offered every Wednesday at 2 p.m. Additionally, we continue to have, or you should also have access to the Slack workspace. And each and all of you are also welcome to request a 30-minute session with a Cerebras engineer and a PSC expert to address a specific topic via the Calendly links that you should have. So I know that's in the documentation, but we can certainly include in the slides before we share them broadly after this webinar. Now, that will be the program overview. Now, let's jump to the Cerebras CS-3 technical overview, which will be presented by Sylvia. Sylvia, if you want to share your screen, or also I have the slides you share and can project them, let me know, what do you prefer?
I can share. I can get that queued
Okay.
up right away here.
Thank you, Sylvia.
Yeah. Awesome. Hello, everybody. I'm Sylvia. I'm with Cerebras's customer success and support team. I work to collaborate with folks over at PSC, including the lovely team here and also a lot of the ML and SDK user projects. I won't dive too deep into this. Moving from CS2 to CS3, Paola already did a good job covering a lot of the specs. The only thing is the second row here. Overall AI compute power, depending on the exact model training workload you're looking to run, we generally see a speed up between 1.5 to 2x over what you would see on um, a CS2. In addition, Paola mentioned those memory X and SwarmX components of the new wafer scale cluster. For anyone who used sort of the um, on-prem system that had been at PSC, that was running in a more traditional kind of GPU-esque pipeline compilation mode, where you can essentially think of the wafer as a really big GPU with a ton of memory. So you're able to fit larger models onto it. Um, with our wafer scale compute cluster, I'll be diving into this, but we've taken a different approach as we've moved up through the hardware and software generations. There are basically three components. Memory X, which is going to store your model weights and perform some optimizer computation. SwarmX, which helps us easily broadcast and reduce weights and gradients across multiple CS3s, and then the CS3s themselves. In this case, we currently have one. We'll be moving up to two very shortly. Projects will be able to use one or both as part of their reservations. And so taking like a higher level view, as a user, a lot of this extra cluster complexity is not something you have to worry about. Similar to how things operated under the CS2 paradigm, everything is still treated as a single logical PyTorch device. Whether you're using our Model Zoo or you're using CS Torch to more uh, do some custom jobs, some custom training loops and workflows, the entire cluster is treated as a single appliance that's more or less a black box. But under the hood, like I mentioned, the memory X is using basically um, commodity CPU servers to host these weights. This allows us to store and handle much larger models than would happen if we were relying on just high performance GPU, or in this case, CS memory, to store all model weights at once. We'll get a little bit into how this operates. Intuitively, you might be asking some questions about latency and how it makes sense to store model weights off chip. But then basically all those weights are going to get broadcasted through that SwarmX tree hierarchy up to however many CS3s your particular job is using, and then broadcasting the gradients back down. And again, all that's happening in a black box appliance that you don't have to worry about managing at all. That's all happening automatically under the hood. So memory X, like I said, model storage is now decoupled from wafer memory itself. We actually stream all the weights layer by layer onto the wafer and perform computation. Don't worry, in the next slide, we'll be getting into how that streaming process works. Between the wafer having incredible amounts of um, fabric bandwidth and incredibly low latency on the wafer itself, we can actually mask this latency extremely well. Um, so you should, again, we still see 1.5 to 2x speed up using this paradigm on the CS-3 as opposed to the wholly on-wafer paradigm we were using before. Um, Weights are never stored on wafer in this process. We store activations instead, because that's kind of necessary to arrive at your gradients after doing layer by layer compute. There are a number of nice things that happen as a result of this. The main one being our weights and optimizer compute and storage are completely decoupled from the number of wafers you're using. If you're used to doing GPU level programming, right, you quickly run into this problem where in order to scale up my compute, I'm also scaling up my memory that I'm working with in tandem with that and making sure that everything is flowing very smoothly and you're not accidentally compute or memory bottlenecking yourself. There are a number of different types of pipeline and tensor parallelism that you have to leverage to have that operate effectively. It becomes very complex very quickly. Um, as we'll see, we're able to achieve very smooth scaling with this weight streaming paradigm using just extremely basic, simple data parallelism, um, which gives us extremely high usability, smooth iteration, and scaling at basically no complexity. So weight streaming in action, right? We have all of our weights happening on our inside of our memory X servers. We stream a layer down onto, this says CS2, apologies, it's a CS3. We can use them kind of interchangeably in this context. Um, so we do a forward pass given our input data. We get some activations out of that. We store that in our on-wafer memory. The next layer gets streamed down of our network. We continue doing these forward passes, accumulating these activations and keeping those stored in local memory, such that when we get our labels in and our loss value basically from our data workers nodes, we can now backpropagate given the uh, activations there, stream gradients back, apply those weight updates, and we basically step back down in reverse through the process we had before. Like I said, the latency of this streaming is masked incredibly well. CS3s have their 900,000 compute cores, each of which has its own local memory, but also its own local I/O. So as a result of sophisticated compilation, we can mask this latency. We can stream massive amounts of data on and off the wafer extremely quickly. Um, in a very distributed fashion, thanks to our mesh computing paradigm. So that's how weight streaming operates. I should have time for some questions at the end. Feel free to hold thoughts till then, but this is a pretty different paradigm for how things usually work, so I want to make sure to address any of those questions. And then, like I said, SwarmX is basically, we have some nodes that operate in this tree structure. It's conceptually very simple broadcast reduce. Um, Again, because we don't have to worry about storing weights on a CS3, we can pretty freely just scale up this broadcast reduce. Every CS3 that you use is using the exact same compilation plan, its own instance of the same weight layer from the model, and we could just scale up data parallelism. Again, requires very little thought from the user. Unlike a lot of GPU parallelism, there's not really a way to shoot yourself in the foot with this either. Um, and we see basically linear scaling from 1 all the way up through the highest I've tested with is 64, but we can theoretically go larger than that. For our intents and purposes, we achieve dead simple linear scaling with the exact same execution model as you would use on a single system. Basically, there's just a single argument you change to go from one to multiple systems, and it just works. Awesome. That's sort of what's changed under the hardware view. Under the software view, if you're familiar with our models do it all, it's gotten a lot beefier um, in our more recent versions. We still cover everything like models and data processors that you would expect. We've included new additions in the NLP sphere, obviously, but also vision transformers, diffusion transformers, multimodal models like lava. We've expanded our suite of tools. You can do checkpoint and configuration converters to and from Hugging Face. If, for instance, you already have a robust evaluation pipeline in Hugging Face you want to preserve, we can do config analysis and validation. If you want to understand exactly how many parameters your model has and what the breakdown is layer by layer, we can do that just by analyzing the configuration YAML file associated with your experiment, basically. Um, there's a lot of common utilities under the hood. We don't necessarily have to get into that. The main point I want to call out there is that bottom one, eval harnesses. We have first-class integration with both Elother AI and BigCode's evaluation harnesses. Any tasks they support, you can port in super easily into your experimental YAML config. And the process for adding in a custom eval task is exactly the same as you would use for augmenting one of those eval harnesses with the custom task. So that's nice and portable. The logic integrates quite nicely. We have a standard trainer and training loop, which supports increasingly a whole bunch of callbacks, whether those be for logging, for data parsing, all sorts of logging and validation. And then finally, all sorts of building blocks you can use, not just for existing model implementations that you can directly leverage or tweak, but we provide all the implementations that get used in the model zoo in terms of different transformer blocks, position embeddings, all sorts of attention implementations, and a variety of under the hood losses. And even if you're doing something highly custom, it can be useful to thumb through these implementations um, to understand our approaches um, and what's been optimized to work well in the model zoo already. Yeah, awesome. Anyone who's used the model zoo before knows it was not necessarily the most easy thing to get set up and running. Good news, we've streamlined this process significantly. The model zoo, you can now clone directly from GitHub and just locally pip install it. Um, It used to be every time you started a training job, you had to specify manually mount paths and Python paths. Um, because the models who didn't necessarily couldn't figure out where those paths were automatically. Because things are now pip installable, we can leverage a lot of that packaging information to infer a lot of these paths. If you're operating under an odd situation and still need to specify a mount path or make sure to point at the model zoo if it's not in an expected spot, you can still specify these path arguments. But for the most part, they're not necessary. Setup is super easy. You clone from GitHub, CD into that directory, just pip install the requirements, and then do an editable local pip install, and you're off to the races. You have your very own um, dev branch of Model Zoo, essentially. In addition, we have an entire command line interface, a CLI for the Model Zoo now. This lets us easily bundle up everything from model training and eval. You can do checkpoint and config conversions via the CLI. You can actually summarize all the models that are currently supported in the Model Zoo. And if you update the model registry to incorporate like a custom model class and implementation, that'll be included in that summary. So you always have access to, at a top level, what your options are for modeling there. And then you can even do data preprocessing and having the CLI describe the docs for a given data processor. Um, all that good stuff. It also has a baked-in LLM assistant. It can answer questions about our hardware, software, and ask questions about anything that's in our documentation. Um, it'll always ask you for permission to do this, but it can process your natural language to execute CLI commands if you're not sure exactly what the incantation for a given um, command or process looks like. And all you need to do that is get an API key that's free from inference.cerebras.ai, and you can have that hooked into the Model Zoo CLI. For an example of how this looks, right? CS zoo is the top level command for the Model Zoo CLI to get a training job executed, I would just say CS-2 fit, provide the path to whatever my experiment YAML config file is, and then I can specify either here or in that file the number of CS3s in this case that I want to use. Very minimal fuss, extremely clean compared to what it used to be, especially. In addition, here's an example of a command we'd use to convert a checkpoint to Hugging Face, specifying basically just the model, the model zoo version we're working in, specifying we want it spat out in a Hugging Face format, point at the config, point to where we want it, and then finally point to the checkpoint file. If you want to convert from Hugging Face into a supported model zoo model, that's also easy. We would basically just flip some of these arguments around. It's the exact same conversion command. And then finally, shifting from machine learning over to the SDK, the lower level device programmability, the Cerebras SDK is still here. Anything that runs on the simulator can still be run on a node of the wafer scale cluster. We've provided a bunch of wrappers to go through the compilation to host runtime to launcher wrappers. Um, Leighton's done a great job. He's provided a couple links there. That appliance mode is really good, just for broad examples and instructions, everything from your very first getting started all the way up through some more robust examples. And then that code examples link uh, gives a little bit more of a walkthrough of differences, things that have cropped up between the CS2 and CS3 hardware and software generations. You can take a look at the microcode over there. And that's my last slide. Paola, I don't know how we're doing on time. If we have time to field any questions.
I'll real quick add something, Sylvia.
Yes.
Thanks for that. Of course, if anyone is doing this and is trying to port their setup to both for like the appliance run piece as well as the WSE2 to WSE3 microcode, of course, we are here to help. So, please always reach out with any questions.
Oh, yes, that's definitely a given. Leighton and I are happy to help with machine learning and SDK projects and questions, respectively. And yeah, that's my overview.
Excellent. You're doing fantastic on time. Like we're just right on time. So thank you so much, Sylvia and Leighton. And now I think we'll move to the next item in the agenda, which will be presented by Mei-Yu Wang from the Ph.D team. So Mei-Yu, do you want to share your screen?
Yeah, sure.
Thank
Let me
you.
share my screen. So do you see the presentation in full
Yes,
screen?
not
Okay.
yet. We can see the Google Slides if you can make it go to slideshow, so you can
Oh,
pick
okay.
one slideshow. Yeah, or that button as well.
Is it working now?
Not quite.
Okay, I think I need to share my let me share my full
If you want, I also have your slides ready, so I can share them for you.
let me share my whole screen and that will probably work that way. Would that work?
Excellent. Yeah.
Yeah.
Now we can keep the
Okay.
presentation. Thank you, Mei-Yu.
Okay, so now I'm going to talk about how to access the Cerebras CS3 cloud server. So, to request access, first, I think, as Paula mentioned, you need to make sure you have an active allocation either through access or NAIR. But on top of that, there are a few items we will need to provide. You will need to provide by email those requested information through Neocortex at psc.edu. So I would like to mention that for any individuals, either you are the PI, students, or any team members who would like to access the server, we will need the information from each of you. You can come in as a combined email or individual email, each way is fine. But in general, the requested information include the full name, email address, your allocation ID, and your SSH public key. So if you already have one, please share it. If you don't, for the next few slides, I'm going to show you some example like how to generate your SSH public key. So, but you can find some information online, for example, through the SSH project website. But for example, if you don't have a SSH key, so here's the example command to type to generate the key. So replace the email in the quotation marks with your own email and run the command. For example, if you're using Mac, you can run the command on the terminal. Or if you're a Windows user, you can open command prompts or PowerShell and run the command. And alternatively, you can also use PuTTY to generate the key, but the steps will be a bit different. But once the keys are generated, you can display the contents of the public key by typing this example command. But there are other ways to share the public key, but please remember, just share the public key with us and don't share your private key with anyone else. And in the bottom, here's the example output may look like, which show the example content of the public key. So if you have any questions, either you can visit the SSH project website or email us with any of your questions. So once you share with us the requested information and we finish setting up the accounts, you will get a confirmation email from us showing the Cerebras cloud credential and also the VPN configuration instructions. So it is essential to make sure you are able to establish the VPN connection so that you can access the server through the VPN connection. So we will give you the detailed instruction of how to do that. But here, we also show the steps here to walk you through briefly. So basically, the first step is to download the Global Protect VPN clients from the web URL. And then using the provided Cerebras VPN credential to log in. And the next, configure the VPN with the provided portal address. And lastly, once those are done, connect to the VPN by entering your credential and password. So once the VPN connection is established, now you're ready to access to the system file SSH. So if you have done it, it's just similar to any connection to any other server. But here is the example command. So please replace the Cerebras _ username here within the bracket with your own assigned username and also the ID _ key with your private key file. But yeah, once you type that in, for example, in your terminal on Mac, it won't prompt to ask you for a password because the authentication will be done SSH key. So that's how you connect to the server. So if you have any questions during the process, feel free to email with any questions. And also you can find the instructions that just show on the Neocortex documentation, and here's the link. So that's all my slides, and feel free to ask any questions in the Q&A session.
Thank you very much, Mei-Yu, for the presentation. A reminder, right, as you guys are generating your SSH keys, it's very important that if you choose to set a password, and you remember that password because it will be needed later on, which can be a phrase or whatnot, a text string. So with that, we are gonna move to the next item in our agenda, which is related to how do you go ahead, how do you proceed with managing your allocation in this new configuration of Neocortex? So let me share the screen right here. And there you go. So this will be presented by Sergio Sanilevich, who is a co-PI of the Neocortex program.
Hi, folks. So yeah, I think the punchline is that we're taking care of things behind the scenes. So in terms of managing your grant, there's no change from the current processes that are discussed in our documentation. So you just follow what you've been doing on the CS2 in terms of logging into Neocortex, using the project command there and so on. Because accounting information from the CS3 cloud is sent into the PSC database, and then from there it is shared with Access and Nair. So again, as usual, you just manage everything by logging into Neocortex, just like you've always done. Then, in terms of grant management, if you have an access grant on Neocortex, just manage supplement extensions, renewals, going from one opportunity level to the next, as discussed in the access how-to. And if you have an air grant, then you manage your supplements, extensions, adding users, and so on, as discussed in the NAIR pilot help FAQ. So no change. We take care of stuff behind the scenes. Similarly, in terms of help and support, and Paola already showed some of that, but again, no change from the current processes. Of course, the main thing to remember is the email. All your Slack channels are still there. As you know, they are specific to your project and also some general ones. We continue to have the office hours that Mei-Yu is providing every Wednesday, 2 p.m., except holidays. And then you can also request, if you have a problem that you want to discuss without waiting for the weekly office hour, you can use Calendly to request office hours, whether it is for an ML project or whether you want your project uses SDK. So these are office hours where we can get Sylvia or Leighton or people from Cerebras to participate along with us. And then
if I may, so as we discussed, it would be good to remind everybody attending, like, how does the Calendly office hours work, right? So we have 2 links. These links are available both in these slides, which will be published in the Neocortex website, but they are also available in the Neocortex documentation. But basically, we have these 2 links depending on where your project is and your question, right? Is machine learning AI related, or if it's mostly related with the Cerebras SDK, you can use any of the 2 links. If for some reason you use the wrong link, we'll make sure to address it. But you just follow the link, you'll be redirected to Calendly, where you'll see a set of available spots, right? So you pick the date that is most convenient to you, pick your time. The slots or the meetings are configured to last 30 minutes. If you happen to need more than 30 minutes to address a specific topic you want to discuss, just let us know here using this field where you will be describing the topic. But what you do is you put your name, email, and just let us know in a little bit more detail what topic specifically you want to tackle. This opportunity to get this on-demand office hours is very interesting because, well, then you will have 30 minutes by default with, as we mentioned, Cerebras expert, depending on what's your topic, right? AI or SDK related. We'll make sure to get the right person in the meeting, and also a PhD research scientist or research engineer. So both the weekly office hours and these kind of on-demand, more flexible opportunity to meet with the team are available. And just a reminder how convenient and how do they work. I think they're a great opportunity. I would like to make sure you guys remember it's out there. So with that, I'll let you continue, Sergio. Sorry for the
no, that's yep, very good. And so as a preview to the upcoming tutorial webinar where we actually show how to use the CS3, but here are some useful links where you can look at kind of in more detail at the things that Sylvia and Leighton mentioned. So this is the actual CS3 documentation, which welcome to explore and actually invited to explore. And yes, we will soon send you an invitation to a hands-on tutorial where we can show you these things in detail. And yes, we are going to share these slides. Thank you, Paola.
Very good. Thank you, Sergio. So with that, we finish. Oh, one sec. My laptop is acting out. So with that, we finish. Well, we proceed to the questions and answers section of the webinar. Now, so the goal for this webinar, as we laid it out initially, was on one hand to kind of give a good idea on how the program is evolving, right? And maybe a little bit of a recap on how it started, how it evolved over time, and what's the configuration that we're evolving into. And very important to make sure that you all know how to get access to the CS-3. So our goal for now is that to make sure that all Neocortex researchers have their CS-3 accounts set up, right? So in the Cerebras cloud, and clarify how is it that you guys will proceed with managing their allocation. And of course, if at any point in time you guys need help, reminder of all the ways through which you can get support. As Sergio pointed out, once the majority of researchers have configured their accounts, have shared their SSH keys and all of that, we are planning to have another webinar where we'll focus more on hands-on and maybe a tutorial to share like how do you run a model and how do you leverage all the functionality available in the Cerebras cloud. And so tackling as usual the AI elements and also the SDK type of functionality. So with that, how about we jump to the Q&A section? And I see that there is one question in the chat by Joseph. I'm gonna read it out loud. It says, if I already have Global Protect installed in my computer, do I still need to download it from Cerebras.net or can I just point it to Cerebras.net portal address? So Leighton or Sylvia, can you guys address the question?
Yeah, I believe the latter. Sorry, I was on double mute. You should be able to just point it at the right portal address if you already have the client.
Very good. And thank you, Sylvia. I see that that addresses the question as I see Joseph share. Thank you. Any other questions that anybody in the audience has for the speakers, for the Cerebras team, or for the PSC team? If not, Mei-Yu, as you have helped onboard users, are there specific questions that may have come up from some of them that we can discuss as a heads up or warnings for those in the audience?
Yeah, I think in general, I think sometimes people generate the wrong or share the wrong public SSH key. So I think yeah, I show example comments. Please double check with the formats and make sure that you key and don't share the private key for sure. And yeah, I think that's usually the question that people may encounter, but feel free to ask questions before you send any information if you are not if you have uncertainty about the steps.
Maybe can you remind people will in the audience and also, well, the recording will be available to all the users, but can you remind people how to differentiate which one is the public key and which one is the private key?
You're muted, Mei-Yu.
Sorry. Yeah, I think it's basically in the file name. It's just end with pub. So PUB, that's the public key. So just share the content of that one. But if you're not sure, you can always find information online, also the SSH project website. And also make sure you find the location of your public keys where it's stored. So I share in the slides, usually stored in the home directory /ssh folder, but it could be different. But yeah, anyway, so that might usually where the questions may arise.
Yeah, thank you, Mei-Yu. Another thing that I have noticed is as people are creating their public and private SSH keys, as they follow the prompts, they're given the option to set a password. It's very important that if you choose to set a password, that you save it or store it in a keychain or any other mechanism that you leverage to remember your passwords, as it has happened that people create the keys and then when the password is needed, maybe it wasn't properly stored and you have to repeat the process and create another pair of public-private SSH keys. So any other questions? I don't see any other comments or questions in the chat. Sergio, any other kind of recommendations for the attendees?
Yeah, I would say maybe spread the word to other people on your team. We will share the slides so you can they and people who were not able to attend today can look at them. You may also want to use those links to start studying the the Cerebras CS-3 documentation on Cerebras. You will see that the model zoo, as Sylvia said, has undergone many changes from the one we had on the CS2. So as you think about how to continue your Neocortex project, I think it will be important to look at that. Also, please check your access and respectively NAIR account or grant. I think there are some expiry dates coming up, so you want to check that and take the respective actions to either renew or to request an extension or we will in the tutorial we'll say more about maybe the details of the conversion, service units between CS2 and CS3. But yeah, I think maybe an important action is to check the expiration date of your grant, and if you want to continue with Neocortex, then see if you need to take any actions.
Thank you, Sergio. As you were sharing these thoughts and recommendations, I remember a question that was asked over email by one of our users that is leverage the SDK in Cerebras. So I'm going to present this question to Leighton so he has a chance to share his thoughts. And in particular, as this user became aware of the possibility to use more than one Cerebras server in the cloud, and well, with the context that this is an SDK user, he is interested in driving more than, well, his simulations by leveraging more than one CS server at once. So maybe the question to Leighton is that supported? What would be some considerations to keep in mind?
Yeah. Unfortunately, at the moment, with our appliance setup, you can only allocate one CS machine at a time for SDK jobs. It's certainly possible that you could say submit 2 jobs at once and do some post-processing. So it is possible to use 2 machines, but you will not be able to use them for one job with the SDK, at least not at the moment.
With the AI pipeline, that is an option at this time,
Yes.
correct? Just to clarify.
With the AI training setup, not only can you use multiple systems at once, but it is totally transparent to you other than just requesting the additional systems. Like it's kind of a single flag to parallelize with the AI training pipeline.
Thank you, Leighton. Is it in the plans, right, for Cerebras to support?
It is in the roadmap, but we don't have a date for it.
Yeah, okay, well, just clarify that at this point in time, it's not yet supported for SDK, but for AI, it's transparent and encouraged. Very good. Thank you, Leighton. So if there are no other questions, maybe we can proceed to closing remarks. We believe at PSC that this is a fantastic opportunity for users, right, to get even more access to Cerebras servers, well, the CS-3 servers in the cloud, and we are very excited regarding this transition. Our team is ready to support and assist with any questions and any roadblock that you guys may find. So please do leverage any and all the support lines that we have described during the webinar. And of course, as we have shared, well, all of you should have received an email. But if you have any concerns as we do this transition, we are more than happy to get your thoughts through email or maybe Slack or any channel that you select to convey those thoughts. So with that,
Actually, I thought of one more question, maybe for
okay,
Sylvia.
let's go for it.
You know, on CS2, we used to have this possibility to, for some of our users, took advantage of that, to combine layers that are supported in the model zoo, but, you know, combine them in new ways. Is that still supported, Sylvia?
Yep, same deal. Basically, as long as whatever your implementation is doing can be compiled down to supported operations, which is always widening, then it'll work. You can customize existing Model Zoo implementations to your heart's content. You can sidestep the Model Zoo entirely and just program in CS Torch directly. There's quite a degree of flexibility there, and I have some experience helping folks port over strange models. So if that's something that fits your use case, feel free to let me know.
Those are the ones we like. Thank you very much.
Excellent. Thank you, Sylvia. Thank you, Sergio. Another question for Leighton on behalf of another user, right? Users that maybe in the past leverage color swapping, how would that work, or what kind of approach can they take as we transition to CS3 in the cloud?
Yeah, so color swapping is a low-level feature of the Cerebras architecture. On WSE3, the semantics are a little different than on WSE2, but this is all included in the documentation. And there is language support for it on WSE3. There's an example in the docs for color swapping. There's also usually when people were using color swapping on the architecture, they were using it for more complex communication patterns, which on the WSE3 can be handled with this feature called message passing that allows you to do point-to-point communication between the processing elements. And under the hood, this kind of uses a variant of color swapping. There's an example in the docs of doing this on the WSE3 architecture.
Okay, very good. Thank you, Leighton. Any other question from anybody in attendance? If not, with that, then we can get all a few minutes back from our day. So thank you so much for your attendance. Thank you to the Cerebras team and the PSC team for their presentations. As a reminder, we'll follow up with another webinar that will be more akin to a tutorial once most of the PSC Neocortex researchers have set up their accounts. And we'll be working closely with you to make sure that all the researchers in your allocation have access to the Cerebras CS3 clouds. And with that, thank you all again, and have a good rest of your day.
Thank you.
Bye.
Bye.
Thanks all.